The input file. Of course, we will need an input file to be able to create a graph, a 3D graph, using the NREP 3D generator. We discussed the input in the input file, but we didn't discuss the parameter line. The parameter line is the line before the set of data relevant to be shown in the graph. The parameter line is important to generate the graph the right way. So in a way to interpret the lines with the actual data from the source. The parameter line gives instructions to the generator. Of course, we could have done it another way, but this is a very direct way to put all the properties in one line in front of the real data. The line consists of a couple of numbers. The first one is the number of companies. Here we see 3 companies, and indeed it's Broadcom, Qualcomm and XP. Here we see 2 companies, GSK and AstraZeneca, GlaxoSmithKline. And the third example is Amazon and Google, 2 companies. So if we look at the original one here, we have a second number, and that's the number of years for each single company. Broadcom here has 2 years, 2015-16. Qualcomm and NXP should have the same years, and they do, so this is a consistent input file. Here GSK, GlaxoSmithKline, has 3 years, and so has AstraZeneca, so that's why there is a 3 over here. 2 companies, 3 years in each block. And here, that's a special one, for Amazon and for Google we have 10 years, but actually we don't have 10 years for Google, we only put in 2 years. It doesn't matter because the number should be the same, 2007 up to 2016, and here for Google we only have 2007-2016, but we should put in all the other years, in this case with zeros. By the way, we use the semicolon here because it's actually an Excel spreadsheet extracted to a CSV, and these are original plain text files. The result is the same. We can use commas, we can use semicolons, it's not important. We can even mix them. Here we see semicolons in the data, but just a comma in the parameter line. The other way around would also be okay. Now the third number is the scaling factor, and usually we have millions or even billions of euros, dollars, yen, and we have to scale them down, or we have to enter a smaller amount, but still if we have the numbers put in thousands, the numbers are pretty large, so we can actually shrink them. This is the scaling factor used to divide the numbers put in. So if we put in, for instance, 100,000 and the scaling factor is 1000, then the result will just be 100. It's not necessary to set the scaling factor because we could also put in decimal points, but it's easier to have the full set of numbers in, and then afterwards divide by the scaling factor to reduce the actual numbers. So it's a little bit of a game. Do we put in a decimal point over here and get something like 19.604, and then the scaling factor will be 1, or do we put in the full set of numbers and set the scaling factor higher? That's a choice. To show the impact of the scaling factor, we will compare 2 different graphs, one created with the original input file we already showed with a scaling factor 1000, and the alternative graph with the scaling factor 5000. Now we will see the difference between the 2 graphs. This is the original graph created from the input file already shown with scaling factor 1000, but this is an alternative graph where we use scaling factor 5000. So this is a very different one. Actually, it affects everything. It seems to affect the font size, the distance, the size of the buildings, but as a matter of fact the whole graph has been shrunk, and as a result everything's closer, and therefore the font, for instance, looks larger. This is the impact of the scaling factor. This is the factor providing an extra space between the buildings. The buildings sometimes are close to each other. The room between the buildings is based on the largest building in the set. The broadest and the deepest building shouldn't be the same, of course. The highest value counts, but sometimes it's too close to each other to have a good view at the graph, and then some extra space can be added. Actually, it's a percentage of extra space between the buildings, so 0 means no extra space at all, just a standard value, and 100 means 100% of extra space, so the space is actually doubled. Now we will show the impact of the distance. If we change the spacing factor, the extra space between the buildings, then we will see another effect. Here the original input file had 20, so 20% of extra space between the buildings compared to the default value, and now we changed it to 80% of extra space, so nearly double value of the default. This is the graph created from the original input file, and here we see the alternative graph with extra spacing. The impact is very clear. The buildings are close to each other in the original one and farther from each other, more space between them in this direction, also in this direction, when we use a higher value for the spacing. Then we have the last value in the series, and that's the font size. Here we see 5 for the font size, here 4, here 6. It depends a little bit on the size of the graph, the scaling factor, how close or how far the buildings are, but the font size can be varied throughout different graphs. And sometimes it's good to experiment with it. A 3 could be too small for one graph and large for another. Some others need an 8, especially for instance when there are banks with their very, very high total assets compared to their equities. It could be useful to have a large font size to be able to read it anyway. Finally, we will have a look at the impact of the font size. Here, originally for Broadcom, Qualcomm and XP, the font size was 5, but now we created an alternative input file with 8 for the font size. The graph itself won't change. It's about the same size, the same distance. Here we see the font in front of the buildings, but also for the years to the side of the rows. And if we change it to the alternative graph, now the font is indeed much larger, both for the names of the companies and the years to the side of the graph. Sometimes it's better to have a large font, and sometimes it's better to have a smaller one. It also depends on the scaling factor. If a graph is close, then the font looks larger, of course,